Hello, Sarah. This is section 5.5. We will probably get done with these notes today because these go really super fast. When they test you on logs on the ACT, this is what they're going to test you over, guaranteed 100%. So you people who are taking the ACT, and even all of you are taking the ACT in April, remember these rules. This section alone is probably where they're going to get most of their ACT questions from, these properties, okay? So just... we're going to go through some different steps of what you're going to do to solve these, okay? I'm going to skip this first box and let's go to example 1 because you know how to solve this. We just did it on the last homework problem, okay? You don't know, but here's the strategy. This is what you do. Here's the strategy. You have an ln of some stuff and I don't know how to solve that, okay? When you get stuck, always, when you get stuck, switch it to the other form. So right now this is a log function, and I always rewrite ln as log base e, okay? When we get stuck, as soon as we get to a point where we can no longer simplify, no longer do anything, we switch it to the other form. So we're going to make this an exponent, okay? E to the second power equals this stuff, right? We switch them around, okay? Now it's easy, right? I can just solve for x. What is e to the second power?
7.3891.
Okay, equals x plus 1, and then what? Minus 1. You can do that in your head. X equals 6.3891. Okay, so when you get stuck, always switch it to the other form, right? If it's an exponent, you switch to a log. If it's a log, you switch to an exponent, and then you can solve it. Pretty darn easy, okay? Now, there are rules for simplifying, okay, which are down here, and this is what they're going to test you over on the ACT. Here's how this works, okay? If you are taking log of two pieces that are multiplied together, what you are allowed to do is to separate those two pieces, but you put an addition sign in between them. And here is how this works. This kind of goes along with the way I think about it is for x's, okay? So let's take a look at this. Let's say we have x squared times x cubed. If we have x squared times x cubed, what do we do with those exponents?
Multiply.
No. We add them. 2 plus 3, right? So it's kind of the same thing with logs. When we're multiplying, we're adding, right? Those two things kind of go together, okay? And in the same way, I guess they don't do it here, but ln is the same thing as a log. So if I have two things multiplied together, I can just break them into two pieces, put ln in front of both of them, and add them, right? Okay, so let's go down here. This is going to be kind of a weird example. They are giving to us this information. We know log 3 is that number, and we know log 11 is this number. They are saying find log of 33.
You just add them.
I don't know what log of 33 is, but I do know log of 3 and log of 7, okay? So you're right, we're just going to add them, but let me show you how this breaks down. Log of 33, we're going to write as log of 3 times 11, right? That's what 33 is. That's 3 times 11. But the rule above says that I can just break those down into log of 3 plus log of 11. When I split them apart, the logs go with them, right? 2 logs, and then when I join them together, you're multiplying and it becomes 1, right? So now I'm just adding those two things. Log of 3 is 0.4771 plus 1.0414, and you get something like, I don't know, 1 point, help me, 5?
Something like that.
I don't know. Somebody add this together for me, please, would you?
6, 1. I'm kidding. I'm good.
5, 8,
1.581.
1.
Or
5185.
Yep.
1.5185.
I have a question.
Yes, sir.
Why wouldn't you just plug log of 33 in the calculator?
I mean, you can, but eventually we'll get to the point where they'll say log of x is this number and log of y is this number, right? Find log of xy, right? So we'll get to the point where it's that, right? Okay, where you can't, I mean, we don't know what x is, so we can't even plug it in, right? Okay, B says ln of 7 is this. This is a piece of information it gives you. Ln of 49 is this. Find ln of 63, okay? So ln 63 is the same thing as ln of 7 times 9, right? That's 63. But when we're multiplying, we can split them apart. So that's the same thing as ln of 7 plus ln of 9. And ln 7 is this guy. And ln 9 is this guy. This is just illustrating that property, right? That when you break them apart, you can just add the two individual pieces. I don't know what that is.
4.1431.
Okay. 4.1431. That's my sister's phone number. End of it. 1431. Yep.
Wow.
Interesting.
You
Very
know
interesting.
your sister's phone number?
This was back when we had to actually punch it in and stuff, you know, like
That was a
we didn't
while
get
ago.
phones until we were like 16 back in the day, folks. So, you know, I had to memorize some things.
Yeah, I know people's house phone numbers.
Same.
Yeah.
7777.
Yeah.
Emma, I used to know
MJ's
numbers.
is
Okay.
3535.
To when we would actually call on.
I don't remember.
And then you'd be like, is Kelsey
Yeah, but like,
there?
so
No,
like,
but if
their
the
mom
parents
would-
answered,
their
you
mom
hung
would answer, and
You
then
hang up.
No.
Yeah, no, I wouldn't.
I
I'd just
would.
be like,
Yeah, I'd say
and
it's
then I'd like
Marcus
slow,
home.
I'd like be like, just wait for her, and then you could just hear her set the phone down and go, Chrissy!
Yeah. And
All right.
you can hear, like, the steps
Let's go to the
going
next
down
box.
the
Here we
aisle.
go.
In the day when you would walk to their house and knock on the
No.
door.
Here we go.
I used to ride my
I don't
bike
wanna
to
waste
Marcus
Sarah's
all the
time. Let's go.
And leave my
X to the 5th divided by x to the 3rd. I'm making this example up and I'm putting it in the next box because when you have exponents like that, what do you do with them when you're dividing?
Subtract.
You subtract. So this would be like x to the 5th minus 3rd and we would get x squared, right? That's like what you're doing, right? So divide means subtract, right? Multiply means add, divide means subtract. So when we're breaking things down, like looking at this guy, if they give me a log of v divided by w, I'm just taking log of v minus log of w. And that's how that works, okay? So they're giving me log 28 is this guy, log 7 is this guy. They want me to find log of 4, okay? Log of 4 is the same thing as log of 28 divided by 7, right? Which means we're going to take log 28 and we're going to subtract log 7. Okay, and log 28 is that number, and log 7 is this number. And when you put those together and you subtract them, you get something.
0.6021.
Yep.
6021, perfect. Okay, all right, now they have ln 18, ln 6. They want to find ln 3. ln of 3 can be written as 18 divided by 6. Be careful because it's not always the first one minus the second one, right? Because they could trick you and give you them in the wrong order. So ln of 18 minus ln 6 is 2.8904 minus 1.7918. And that is something.
1.0986.
Okay, there you go. All right, good? These are easy. These are easy. Until the next part. Okay?
Yeah, wow.
All right. So, before we move on to this last principle, because this is the last one, okay?
Oh,
The
this
first
one is
thing-
easy.
Here's my strategies. STRATEGIES. It's going to be one of these things. These are going to be things that you're going to need to remember for the ACT when you have this, okay?
Yes.
All right, first strategy, number 1, is switch between log and exponential functions. Okay, that's one strategy for evaluating. If it's a log and you're stuck, switch it to an exponent. If it's an exponent and you're stuck, switch it to a log. That's one strategy, okay? The next 3 strategies all go together and they involve breaking down. So break down by. And number 1, well, I guess I'll call it 2. Number 2, multiply equals add, right? Okay, so when you're multiplying 2 numbers together, you just add the values, right? Okay, number 3, or like the second one that you break down by, divide equals subtract. Okay, we just broke those down. Okay, this one right here, number 4, this is the other thing that you are allowed to do. Okay, and before I write this one down, I'm going to show you why this works. Okay, are you ready?
Yes.
Off to the side over here, write this example down. This is the example I use every time I do this, okay? Let's say I have log, I don't know what I want to do. Let's say I have log of 1,000, okay? Let's say I have log of 1,000, okay?
Yep.
All right? This is equal to log of 10 to the 3rd power, right?
Mhm.
Okay? Right?
Yes.
Right?
Yep.
Which is the same thing as saying log of 10 times 10 times 10, right? That's what 10 to the 3rd power means, right? And that gets me to 1,000, okay? All right, but we just had a rule that said that if you're multiplying, you can add, right? So log of 10 times 10 times 10 is the same thing as log 10 plus log 10 plus log of 10, right? And that can be simplified as 3 of them, right? There are 3 log 10s, right? That's how many there are. So here is the rule. The rule says that if you have a log, you can go straight from here to here. What happens is if you're taking log of some number to some power, this power can come down in front. That's how it works. And this is a proof of that, right? This is how that works. That's a proof of why that is true, right? The 3 or any exponent that you have in the top can come down in front, and then it's easier to simplify, right? So I'm just going to write that down over here in that fourth rule is that log, I'm just going to say log of 10 to the third is equal to 3 log 10, okay? So they're saying, like if you look at their example in this box, it says log of v to the k power. That k can just come down in front, right? Or ln of v to the k power. The k can just come down in front. Anytime you have an exponent, we don't like exponents. We would rather deal with something that looks like this than an exponent, right? So we can put that number down in front. Only if it's a log, okay? Now I explain this rule every time, and there's some kids that like, especially in Algebra 2, when we get to the end of the year and we start doing a little bit in logs, they're like, okay, if I can do that, like let's say I have log of x squared, right? The 2 can come down in front, and that can become 2 log x, right? But then they start to see things like x squared, and they're like, oh, well, that's the same thing as 2x.
Nope.
It only works if there's a log there, right? X squared is obviously not the same thing as 2x. You can't just move this guy down in front. Not the same thing, okay? So don't get lazy. It has to have a log in order to be able to move it down in front, okay? It can't just be an exponential function. It has to have a log in order to move it down in front. All right, so let's go down to this one. Use the power law and find log of the square root of 6. We know what just log of 6 is, but we want to find log of the square root of 6, okay? Now, nope, we can't do that. The square root of 6. Okay? Now, we just dealt with powers, right? What is 6 as a, like the square root of 6 as a power? What's a square root as a power? Nope. What's a square root as a power?
Half.
A half. This is like 6 to the 1/2 power. But that means that
Half of log 6.
the half can come down in front. So half log 6, right? Okay? But we know that log 6 is 0.7782. So I just multiply those two together, right? 1/2 times that.
Which is?
Does this make sense? 0.36? No, 35 something. I don't know. Give it to me.
Just kidding, I'm dumb.
Go, Marcus.
Oh, what?
0.
No, it is 36 something.
Half of that.
3891. There you go. Okay, do you see why we multiply that by half? A square root as an exponent is 1/2, and then you bring the 1/2 down in front. Okay? All right, the same thing. We know ln of 50, but we want the cubic root of 50. So ln of the cubic root of 50 is ln of 50 to the 1/3 power, or 1/3 ln 50. And so we just take 1/3 times this 3.9120. And you can do that in your head. Hold on, don't give it to me. 1.3040. Yeah? 1.3040. Look at that. All those numbers are divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. 12, so we have to skip 1, is 4, right? You can do that. You can do that in your head. Okay?
Yeah, I can do that.
Yeah.
No problem.
You can do that in your head. All right, now, next one. Example 5. These are where they get really kind of yucky, so pay attention to these. They want us to write these all together, okay? Write these all as a single log. Okay, first of all, how many pieces are there? 1, 2, 3. And there's a plus in between these, which means that we're going to eventually multiply those. There's a minus here, which means we're going to divide. Okay? So that's how that works. But there's one thing that I can move first.
Probably.
You can move 4.
The 4 to the
Oh, yeah.
back. That's the only one that has a 4 in front, right? The only one that has a 4 in front, so the 4 can get moved to the back. All right, now we're going to multiply stuff. So we're going to write this as one log. So I have an ln in front of the whole thing. This whole thing, okay? The first two we're going to multiply. So we're multiplying the 3x and x to the 4th. 3x times x to the 4th is 3x to the 5th. But then we're going to divide by,
Why
What?
are we dividing?
because the minus is 3xy. Okay, we can simplify that even further. You see what we just did there? We're multiplying and we're
3x to the 4th.
ln of what? Nope,
3x to
nope,
the fourth.
nope.
It's X
Cancel
to the
those.
fourth.
Oh, x to the fourth.
X
Cancel
over
this
one.
x with one of these, so this is 4. So we have x to the 4th over y. Do you see how we did that?
Yeah.
Okay?
And that's
Multiply means you're adding this, or excuse me, adding means you're multiplying this stuff. Subtracting means you're dividing. Okay, now we're going to do the same thing. How many pieces do we have here?
2.
Simplify this thing. Okay, so we're going to put stuff together here.
This is ugly.
Okay. Rather than putting this together, I'm going to break it apart a little bit more because it's kind of all messy, right? Let's break it. Yeah, let's break it apart. Let's break it apart. Okay, so this stuff right here, if I break that apart, division means you are going to subtract. No, check this out. Division means you're going to subtract. So I have ln of the square root of x minus
Raise your right hand.
ln of x. Okay? Everybody watch. Do you see what we just did there?
Well, that's to the half power.
Wait,
Okay.
I'm confused.
So I took that first piece and I'm breaking it down. I'm just putting them all in one line. Because we're going to see what cancels out. I think some things are going to cancel out.
Oh, I get it, because it's
Yeah?
divided,
Order.
so-
Divide means subtract. Okay? Good?
Don't get it.
All right. Now, further, this guy is to the 1/2 power, which means this is 1/2 ln of x minus ln of x. Right?
Yeah, so
ln x
negative
and
1/2
ln x, so
ln of
it's-
x.
Right, right. So this is like 1, so we can put those together, right? Yeah?
Yep.
Negative 1.
So negative 1/2 ln x. Right? Do you see how we just did that? All the way through? Okay, that's a little bit nicer. Okay? Because what number is in front of ln x?
I know.
There's one of them, right? There's one ln x, right? So I just put that in there just so you can see 1/2 minus 1 is negative 1/2. Yeah?
Yeah.
Okay? All right, so that's that first piece. We've simplified him down. Okay, we're going to do the other piece.
Move
Okay?
to 4.
So let's do this. We're going to move the 4. This is to the 1/4 power, right?
Yes.
Okay? So I'm going to put the 1/4 in front. So this is 1/4 ln of
11.
ex squared. Okay?
Move the 2.
Nope.
Nope.
Nope, not yet.
Last two.
Not yet. 1/4 e or ln ex squared. Do we see how we get that? 1/4 comes down in front. Okay?
LN.
All right. So now I want to separate these two. These are multiplied, right? Multiply means add. So I'm going to do ln of e plus ln of x squared. Okay? Now the 1/4 on the outside goes to both of them, right? So I'm going to do 1/4 here and 1/4 here, right? Because that goes to both pieces. Okay?
Oh, okay.
All right. Good. Yes?
Yeah, this one is hard.
This one is hard. Yep. Okay. All right.
This stuff on the ACT.
Do we see where we're at right now before we move on? Are we okay?
Emma.
It's not going to be this hard, but the same idea. The same idea. It's not going to be this hard, but the same idea. So like probably the same difficulty as like this one was,
That's what I'm asking.
right? Okay. So there's that. All right. Do we get where we're at?
Yeah.
Now let's see what we can do. ln and e.
Oh, he just made a call.
You can find that in your calculator. What is ln e? What's ln of e?
Hold on.
Log e.
Just one.
ln of e.
ln and e cancel each other out.
Just why are you doing the one?
Wait, hold on.
ln and e cancel each other out.
It's
Type
a
in your
Taylor
calculator.
Syntax.
No. Type in ln of e.
The e wants to put next.
Well, then just put it to the first
I
power.
think it was the one that we did today.
It's 1.
It's 1.
This should be
So
4.8.
this is just 1/4 times 1, which is 1/4.
8%.
Okay. Plus, what can we do with this guy?
So 1/2 ln
And
x
that should be
squared,
joules
and then
per
it's all gonna
calorie.
equal out.
And that
Okay,
should be
now hold on.
22.
Let's take the 2 down in front.
0.98.
What's a 4th times 2?
Oh, an eight.
And no.
Nope, that's a half times 2. What's a 4th times 2?
2/4.
Oh.
1/2.
That way.
This is 1/2 ln x.
1/2 ln
Okay.
x.
All right, so let's put everything on the front. So we have this piece and combined with this piece.
It's a 4.
Well, negative and positive, just like
Negative 1/2 ln x, positive 1/2 ln x equals 1/4.
So you would multiply because there's a plus because
I
there's no
hate it
ln
here.
in all
That was
of them.
Right.
stupid, and if I ever do that again, I'll be cheating.
Okay?
Oh my
Good?
It dropped my grade.
it
Alright.
got my grade 5 points.
Last one.
You guys talking about AMP?
Huh?
What are you guys talking about?
Physics.
Oh, I'm not in either.
Do I ask you a Richter scale one? No, we're going to skip this example.
Oh,
Okay, all done. Happy Friday. We will turn this in on Tuesday, though, so get to working on your homework.
Merry Christmas.
I know.
Get to scooting.
But now I have to dig my